Sound is good. Perfect. So welcome, and today's topic, we are going to talk about how to use Docker to improve our reproducibility in the research work, because it's pretty important and it's pretty helpful to improve the quality of our research outcome. And I will share more about this later in the slides. A little bit information about myself and about WARA software. So my name is Long Zhang, and currently I'm doing my PhD study at KTH. So I'm founded by WASP 4 years ago. This is my this is the end of my 4th year study, and still have 1 year to go to defend my degree. So hopefully everything goes well next year. And currently I also act as a research assistant at WARA-SW, which is the arena for providing software support for WASP faculties and students. And my research topics are mainly about self-healing software and chaos engineering. So it's about software reliability and fault injection techniques. And regarding WARA software, so if you just join this WASP community recently, WARA software or other WARAs in this WASP community are really good platforms for providing support for students to do their research. And for our WARA software platform, you can have more information in this GitHub repo. And the goal is to provide an integrated platform for us WASP students to access software related resources. For example, the infrastructure, if you need any cloud computing resources, not any, but if you need some cloud computing resources like virtual machines or some other platforms like Jupyter notebooks, you feel free to apply, trigger an application, and we will help you to arrange some resources for the experiments. And also we share software artifacts or software datasets, so you can use these datasets for your experiments and have new research outcomes and analyze your models using these datasets. And also today's event, we also provide different tutorials for students. For example, if some students focus more on machine learning or focus more on autonomous system, then maybe they have a less background of the software development. Then we can organize some workshops or provide some tutorials how to use these software platforms to improve the research work and to improve the productivity and reproducibility. So the content of this WARA software, we provide this infrastructure support, as I have already introduced. And also we share this WASP project course outcomes, because I think sometimes you will take a WASP course called the WASP project course, and then you have some collaboration with the other PhD students. And if it's in the field of software, you can present or disseminate your WASP projects on this platform. And you can also gain some support during this project course. So this is some brief introduction to WARA software. And then regarding today's contents, we will have 4 parts. The first 3 parts, basic concepts about Docker and the reproducibility, and also the short demonstration for basic usage of Docker, and also use Docker to improve the reproducibility. So this part I will do more a demonstration or the presentation, and you can ask any questions if you want. Hopefully we can make it before the sun goes down, right? So it's around 3 p.m., which is pretty early. And after that, you can stay and try Docker by yourself. We provide you some online platforms or tutorials. And then if you have any questions, I will be standby and help you to address them. And okay, so for this interactive notes, I can show you. This notes, you have the edit access there. So, and if you need, you can post questions here and we will discuss them together. And also let me share the slides with you directly here. So you can click all the links, which is a bit more convenient. Share everyone, I say, commenter. Yes. Okay, now you have access to my slides. And let's start with the part one. Before that, does anyone have any questions? If you need, we can directly discuss like the concrete setup. Does it work for you? Okay, there seems no questions for now. And let's continue. So part one is about like the basic concepts and about Docker and the reproducibility. I think first of all, I can give you a brief introduction to Docker or to virtualization, because Docker is a concrete product or is a sort of techniques which is based on the virtualization. Like it provides you this virtualized environment, and you can install dependencies, run your software there, and to improve the reproducibility. So overall, what is virtualization? And I think this concept was brought like many years ago with the development of our computing infrastructures. With the act of creating a virtual version of something, right? Because when we design this like super powerful machines, it provides you lots of computational resources. But the thing is, you have to share these resources or schedule these resources with different teams. So if I directly lend this powerful machine to one team and then they take turns to use that, it's not super convenient. So like scientists or developers, they invent these virtualization techniques to actually split or divide the computational resources of this hardware or the platform so that it can be shared by different teams at the same time. And another important thing to be mentioned is I think the virtualization happens at different layers. So for example, you can virtualize this hardware platforms directly. So you have different operating systems on top of this like a powerful machine. And you can also do some virtualization on top of the operating system. For example, you can use like Docker, or you can use this VirtualBox, some virtualization software to install different operating systems. Even though I have a Mac OS system installed, I still can run Windows on top of it using these virtualization techniques. And also, if you have heard of this Snake platform, it's like the Swedish, I think it's national infrastructure for computer science or for computing. I forgot the concrete name, but the Snake platform also provides you like different computational resources. And one of the resources, one of the platform is OpenStack. So they use OpenStack to provide you these computational resources. And on OpenStack, you can create virtual machines and to set up your own, for example, private network there to do your computational experiments in the cluster. And then OpenStack is another sort of virtualization techniques. So they virtualizes the bunch of like computers, and then you can create some virtual instances there. So this is about virtualization, and come back to Docker. So Docker is one of the virtualization techniques. And as I mentioned, the virtualization happens at different layers. And Docker, it is an OS or operating system level virtualization technique. So it means that the Docker platform shares the resources or the kernel with your host, with the target computer system, but it virtualizes the running environment on top of it. And based on its definition, it's an open platform for developing, shaping, and running applications. And I think it has been open sourced. If you can, check this GitHub repo there. Okay, and here are some links. Like Docker is not the only virtualization or containerization platform. There are actually lots of different products there. So if you take a look at something like this, the tutorials, you will find a bunch of different runtimes or containerization tools. So you can pick up the one tool based on your concrete requirements. But Docker is pretty popular nowadays. So we just use Docker as as an example to introduce you some concepts and also like the connections between these containerization techniques and the reproducibility problem. Okay, so in order to try Docker, I think it's better to run Docker directly so we can feel like how Docker looks like and what's happening behind some commands. And for this, I will directly show you a really simple command, Docker run hello world. And this is also like a part of the installation steps on their documentation. And if you run if you run this command, Docker run hello world, after installing Docker, you will have some sort of outcomes messages like this. So the first line, like, okay, unable to find the image, and then we look at a term like image in this Docker community. Unable to find image hello world latest locally. So it's pulling from library hello world. And then it downloads the new image for this, and it outputs the messages of this container after running this container. And basically it gives you the confirmation that you have already like successfully installed Docker. But the thing is, what's happening behind this outcome? And it mentions several terms. If you are like the beginner of Docker, you might be curious about them. So for example, to generate this message, Docker took the following steps. And the first one is it's the client. So what is the Docker client? And it contacted the Docker daemon. And what is the Docker daemon? And then Docker daemon pulled this hello world image from the Docker hub. So we keep having more terms here. And what is the Docker hub? And then the Docker daemon created a new container. Okay, so we have like these pairs of concepts, container and image. So a new container from the image, which runs the executable and provides you this outcome. And if we take a look at this in a more like systematic way, we will have this architecture of Docker. So I think we have already like covered all these terms when we run this Docker run command, but the thing is how they are connected with each other. Okay, so Docker client and Docker daemon. So these two are sort of like binaries or services running on your local host, on your host machine. And the Docker daemon is always running after you installing Docker. So it's executed as a service. And the Docker client is a tool that you use to communicate with Docker daemon. So you send like commands, you use this Docker run command, right? Docker is a binary and it acts as a client. You use this to interact with the Docker daemon process. And then when we run this Docker run command, we give it an image name. So the Docker daemon try to find this image locally, because it has this like cache mechanisms. If you have already downloaded the image, you can directly use the image from your host instead of downloading it again. But since it's our first time to run this hello world image, it does not find it locally. And then the Docker daemon try to pull the image from Docker hub. And actually Docker hub is one of the Docker registries on the internet. You can set up other Docker registries, and also I think some open source platforms also have their own Docker registries. You can also use your own private Docker registries. So the thing is, the image are stored in these registries, and the daemon pulled the image from the registry on the internet, and then it initializes the container based on this downloaded image. So you see, finally, we have this running containers on your local machine, and it provides you some output. So this is a really like a simple example, but it gives us the overall picture of Docker and how these components interact with each other. And the thing is how we use Docker to create or to like utilize more complex images and to make it as our own experimental environment so that we can run our code there. And this is the goal of today. So we will like use a machine learning project as an example to show you how to Dockerize them and how to use these like Dockerized images to run your experiment. But before that, since this is the first part, let me introduce more about the concepts. We have already like taken a look at Docker and how to run Docker using a really like a simplified example. But now, what is reproducibility? And I think if we like have began to write some research papers and have some discussions with the reviewers, they might mention this like, okay, how to reproduce your results and how to properly set up your experiment environment. Okay, so about reproducibility overall, it's based on this Wikipedia page. It is like a major principle of the scientific method. And also it's a result obtained by an experiment or study. I think it makes sense, like it should be achieved again when the study is replicated with the same methodology by different researchers. For example, when I read a paper, and they present a really nice experiment result, and they also open source their solutions like the experiment setup and their source code. And then I feel curious, like how, if I can run it locally, and if I, for example, replace some of the data sets or the algorithms, whether I am able to see the differences among them. So if I feel like to try their approach, I need to properly set up their approach first. And this story starts from like the like 300 years ago. So the first one who gave us a stress about this reproducibility problem is Robert Boyle, and I think he's chemist in England. So during that time, Robert and the other chemists, they feel very interested in this vacuum problem. So like how to research the vacuum, the different like the different problems or findings of this vacuum quality, and then they have to like build their own experimental setup. So for Robert and his team, they invent a setup called iron pump, which is a pretty complex setup during that time. And they use this air pump to produce vacuum, like some containers with vacuum, something like that. And then they can like share the findings with other scientists. But the thing is, I think in Amsterdam, there is another chemist whose name is Christian. And Christian has his own air pump, which is a different one from this robust air pump. And Christian reported some new interesting findings about vacuum. And after reading Christian's finding, Robert tried to reproduce this effect using his own air pump. But the problem is he never succeeded during that time. And because Robert was pretty authoritative in England, and there are many like scientists, so they have lots of arguments about these new findings, and they say, okay, if we can't like reproduce your findings in England with our own equipment, we cannot accept your findings. So that's sort of serious arguments. And the final solution is Christian finally went to England and gave them lots of guidance to how to set up the experiment and how to reproduce the result. And finally, they accept the like newly founded effect of the vacuum. So this triggered lots of discussions besides the chemistry problems, like how we can maintain the reproducibility of one's research work and how to improve the reproducibility of it. Especially nowadays, like we are trying to learn lots of machine learning techniques, and I am not an expert, or my major is not in machine learning. So it feels like sometimes we have this black box, and with some black magic, then we have a pretty promising outcome. But the thing is how to learn their approach and reproduce it on my local environment. So this is a sort of interesting problem. and have some more discussions about scientific process and also reproducibility. So when we write a research paper, usually we have some hypotheses, right? So we propose some research questions and we think, okay, it works in this way and we have to prove it. That's how we come up with experiment designs and we write our code to actually do the experiments. And during this process, we have to, for example, collect the data. We have to train our model with respect to machine learning models. And then we have to analyze the result. So we do some data analysis. And then finally, we report our results and discuss the findings with all the others as a research paper. And the reproducibility usually occurs in these two phases, like data collection and the data analysis. So how I can collect the data or filter the data in the same way, and how I can actually run your experiment and do the same data analysis, whether I am able to have the same result, etc. So we will also focus on these two phases and to see how to improve our reproducibility. And as a disclaimer here, so since we are discussing like a reproducibility and to discuss how to use Docker to improve the reproducibility, I would say it's not a yes or no problem. Like using Docker, okay, you have your reproducibility. No, I don't think like that. Of course, we have more research work. Like you can reproduce the result in a more deterministic way. Like you have exactly the same outcome of this software execution, and then it has lots of complex problems like how to trace the execution, how to monitor your operating system, system call invocations, etc., to have a deterministic result. So this is one aspect of reproducibility. But today, I think we will focus more on how to improve the reproducibility. So without Docker, like we have lots of documents and we provide you lots of information. Still, it can be a challenge for the others to run your experiment. And the thing is with Docker, we can like make it a little bit easier for the others. And the reproducibility is improved, but maybe still not in a perfect way, right? Yes, so just to control your expectations, we will not like use Docker to, after this workshop, you will not be able to deterministically make your experiment like always have the same outcome if that is your goal. Okay, so about reproducibility, nowadays there are several crises or several serious problems. So, for example, for this like 2018, there is a poll of 1,500 scientists. This is conducted by Nature, and it's reported that 70% of them had failed to reproduce at least one other scientist's experiment. And I think it also happens during my PhD study, like when I try to reproduce the other researchers' results. So the paper is super interesting. And the problem is I cannot get their result, and I cannot even make their like open source the GitHub project execute it on my local environment. And to be more specific, so there are several technical challenges of reproducibility in the world of software engineering. So for example, for this challenge, Dependency Hell, let's look at the picture first. This picture, it's a Java project. I think the project is called Pathfinder. Yeah, many users use it as a library, I think. And the Pathfinder, it defines lots of dependencies, because when you develop a Java project or some other tools, it's pretty common that you declare a bunch of dependencies so that I do not need to write everything by myself. So it declares like dependencies. And the thing is, these dependencies also declare their own dependencies. So it becomes a tree of dependencies for this project. And as you see, it's pretty complex. And some of these write nodes, I think it means like some of the dependencies have been outdated. So there can be some problems here. for example, the compatibility problem in the software build. And the thing is, sadly, less than 50% of the software could even be successfully built or installed because of this dependency hell. For example, as a Maven project, you can like run Maven install or Maven compile in your local environment, but sometimes there are conflicts with your local environment. For example, this dependency does work with your local binaries or local environment, for example, the GTK versions, etc. And then you get an error after like running the compile command. And another challenge is this in-process documentation. Not really technical, but I think, yeah, it's a technical challenge, and also it's because of the developers, right? So sometimes we don't provide really nice documentation or enough documentation for one open source project. And then based on this documentation, we will have lots of different issues which we cannot find a solution there. And this brings us lots of like challenges about reproducing the results using their GitHub project or open source project. Okay, so the third one is called code rot, and the code rot has the definition. It is a slow deterioration of software quality over time, and there are several reasons which can cause it. For example, this environment change. When we upgrade our operating system, when we upgrade our JDK version, if you run Java projects, then you might not be able to run the previous projects, the legacy projects in your local environment. And also this onceability. And onceability, I think it means like the ability to reinstall or reset up the environment once you have already made it. For example, after installing your operating system or after like setting up everything about your development environment, you may not be able to remember everything, right? Okay, how did I install this tool? How did I install this software components, etc.? And then it becomes a barrier for you to improve the reproducibility, because sometimes because of the dependency or because of the other issues, you have a problem, but actually you don't know how this was addressed before. And also for some unused code, we write code and not all the code are covered by our test cases or are upgraded with the development of your software project. And then sometimes it will have some conflicts with the newer libraries or with the newer feature when you add into the project. So it's also like related to this rarely updated code. And we have mentioned these several challenges: dependency hell, in-process documentation, and also code rot. And now we are going to see how to use Docker to address these technical challenges and what sort of nice features provided by Docker can be helpful for these challenges in the reproducibility problem. And I think I have finished the introduction of this part one concepts. Does anyone have questions so far? Let me check the chat box first. Okay, there is no questions. And if you have questions, you can unmute and directly ask. Otherwise, we can continue with the second part. Okay, seems not. And then let's start with this demonstration. So for part two, I will give you a demonstration about this basic usages of Docker, and also we can have more discussions about like different features provided by Docker and what the issues we can address using the Docker environment. And in order to demonstrate Docker, I have to identify a project which is not that complex, but also it contains the necessary steps about how to use Docker and how this is connected with the reproducibility problem. So my final recommendation is this one, admin version 2, and it's use the PyTorch platform. I can directly show you here. So this is like a I would call it a filter or some interesting tools. So you can use this AnimeGAN tool to generate or to make your picture with animation style there, right? And also, I read it via news, and it's becoming quite popular nowadays. Like people use it to generate their own avatar. And I think, okay, it's a machine learning project, and it has not been Dockerized yet. So it can be a good target for us to try it a little bit. And I think it's pretty interesting. Yes, but to be honest, I'm not an expert in this field, and I rarely use PyTorch and other machine learning tools. But I think it's good because I can focus more on the Docker side, like how to Dockerize it and how to address some of the problems that we have mentioned, like in the part 1. Okay, so if we open this AnimeGAN version 2 GitHub repo, right, we will have we will see the brief introduction of this project and also the basic usage of this project, how to run the commands using different methods like this PL library or using the torch library in Python, and also how to train the model, etc. So usually these projects or our machine learning projects have 2 different like phases, right? So we use input data to train our models. And then we also use the like a pre-trained model to generate some results based on new inputs. And the thing is, for this training process, it needs lots of computational resources. And because I'm using my laptop here to do the workshop, I may not be able to show you like how this training process is containerized. But still it's possible and it's similar compared to the other step. So today I will show you like how to use the pre-trained model to generate the pictures we want, and then how to use Docker to containerize this project and make it more convenient for the others. So that's the goal today, and this is the project. Before using Docker, the first question is how do we develop this application? How do we do this project without Docker? And as you read this documents, right? So if we don't have Docker, I think the first step is to check out their GitHub repo so that you can run the project locally, right? And let's go to the WARA-SW folder. Workshop version 2. And I have already checked out this AnimeGAN project here. And it's in the main branch, and you see everything is there. And okay, so how to use that? The basic usage is this command. So we run Python test Python, this script, and we give the input folder, which contains a set of images. And then we can also define the device here. So thanks to the PyTorch library, we can use both CPU and our GPU resources to do this project. Okay, so I think I have prepared an image here. And let me introduce this my cat. Her name is Bang, who is super naughty. And okay, now I'm going to generate an avatar for Bang using this project. So I put the Bang's image into this folder, and now before run the actual script, I think the first thing is to check their requirements, right? So this requirements.txt file. Usually, if you use a Python script, Python project, they gives you this requirement file which declares the dependencies of this project. So if you haven't installed Torch, you haven't installed Torch Vision in your local environment, you cannot run the project. And also, if you haven't like installed Python 3 here, you can't even like execute Python command. So the thing is, when you have a really new environment, I have to install Python first, and it's Python 3. And the thing, if you want to, sometimes the default version is Python 2, and then you have to upgrade the version or have different versions of Python. And after installing Python, we have to use this PIP, the package manager, to install the dependencies, right? To save some time, I have already installed it. Otherwise, it just takes you some time, and it downloads this PyTorch and Torch Vision libraries from the internet and install it locally. So after installing Python and installing the dependencies, finally we are able to run this project. So Python test, and then we give the input directory, which is the current path, and I think it's this one. And we can also give the output directory. Let's give it to images results. By default, it's using GPU resources, but I think we will have an exception here because my laptop, it does not have a super powerful graphical card. So you see there is a CUDA out of memory runtime error. But it's fine. It just confirms you like it's running with your GPU card. And if you have a powerful GPU, it can really accelerate this execution. Okay, so then let's use CPU instead. And you see it's loaded, it loaded the module. And I think this is a pre-trained module, right? You can also run their training script to generate such different models. Okay, so the image has been generated in this results folder. And yes, now we have a really animation style avatar of bomb. So this is the example of this anime GAN project. So we can give pictures and we generate different interesting pictures here. And I do it locally without using Docker, right? So this is the simple way. And the thing is, when you have a more complex project, and then you have like more dependencies you have to address, or maybe there are some potential conflicts with the with my like a running environment if it is your project. So it looks easy, but there can be potential issues when you install Python, when you install different dependencies, and also maybe the project is not written in Python. If you are using Gradle, Maven, or some other like languages, then you have different problems. And now we are going to use Docker to see if we can make it easier for the others to reproduce the result. And let's start from using existing images. So I have already like shown you about the architecture of Docker, right? So it pulls the image from one Docker registry. And just now we tried with the Docker Hello World image. And now we can try like other images, because for this Docker registry, it provides you tons of images that you can directly use, and it has different running environments, which is pretty good. And I will introduce the registry later during this workshop. So the first command, let's try a little bit with this Python image, because we are using Python 3 in this in this project. And then yes, we can use an existing Docker image called Python, and we can give the version here. If you want to use Python 2, you can also have the Python 2 image in their Docker registry. Okay, so in order to use this, we rely on this Docker run command. I have already run the Docker run hello world, and if you use this -- help, you will see more options of this Docker run command. And then, for example, you can set up the limit of the memory limit, and you can also define the network, whether to remove the container after you stop running the container, etc. So this is like one suggestion when you try to explore some new software platforms, you can simply run with the help command to see, okay, their explanations, etc. And there is also a nice tool called TLDR, too long don't read. So if you like use these terminals a lot, you can also try TLDR, and then you just use TLDR Docker, and you have a really brief introduction about how to use these Docker commands. And it works pretty fine with lots of commands. Okay, this is a like set topic. And for our project, let's run this Docker run. We have to give it this option -it. And if you check the help message, what does -i mean? It means interactive, because we have to type more commands in this container. So we have to have an interactive terminal or the interface with the target container. And I think T also means a sudo TTY. So I think it's like the terminal at this one. So we have the interactive terminal with the container here. So we run docker run -it, and then we give the image name and also the version there. Okay, after running this, you see we have already entered the container because I have already downloaded the image, so it runs pretty fast in second. And then we have entered the container, and you see the terminal is sort of different, right? We cannot run any bash command here because it's directly running or giving you the Python console here. So this gives us a new concept about like executing a Docker container. And the concept is about entry point. So when you run an image, especially from the Docker registry, it has a default entry. So when you start a container, it directly runs the command. So as a Docker entry to start this container. For example, for this hello world Docker image, yes, the entry is sort of the binary or the script which like outputs the following information. So you don't need to give more commands here, and it directly executes what you want. Because it's a Python image, so the entry is the Python console. So you can directly run the Python code in this container. But the thing is, we would like to reuse this Python environment, but still we want to make it like applicable for our projects. So we have to install the dependencies, and then we have to run that script to generate the image for us, right? So we have to run this Python image. We start a container, but we don't need this console. Actually, we need a bash console. And if you would like to do this, we have to redefine the entry point in this command. So we give another entry point, basically. And the point, I think, is bash. You can also use sh or other like terminals interface for this container. Now you see we have entered the container, and we have made the entry point as a bash, so we can run our bash commands here, like ls and others, right? Okay, so it's perfect that we have this Python 3.6 running environment in this container, and everything has been virtualized, isolated. So you have this isolated running environment. It's different from your local host. You will not like mess up your local running environment, even if you haven't like installed Python there. Okay, so now we have Python installed, and let's make a directory to have our application. So let's enter this application directory, and the first thing is to check out this project, right? Let's do that. So we have this project's GitHub link, and we can clone the repo here. And it's pretty good that for Python 3, the image has already installed GitHub, the git command for you. And then we have this PyTorch admin gun project. Okay. And now we can install the dependencies. So pip install, and we give the requirements. Now you see, it begins to download the Torch library and also like the Torch Vision library. Then we can install these dependencies in this container. So it's not in your local host now, because I have already installed the dependencies, right? Now it's installed it again, because in this container, everything is isolated. We don't have this dependency installed. Okay, so in order to show you the whole procedure, let's wait a little bit and to see what happens afterwards. I think you can just imagine like when you start up the container, though the virtualization happens on top of the operating system, so it shares the kernel with your like a local host. But the thing is, you still have this like isolated running environment. So if you don't interact with the kernel stuff with the, for example, the operating system invocations, system call invocations, and you focused more on the application side, then it's totally fine, and it's just acts as a virtual machine. But the thing is, the virtual machine also virtualizes the hardware for you. That's the difference between containerization and also the operating system's virtualization. Okay, and now I think we have we are almost there. And actually, this is a good example. Like I show you about the dependency hell, the challenges there, and in this requirements.txt, if you remember, it only defines 2 dependencies, right? And these 2 dependencies actually has more dependencies, so transition dependencies there, and then it install like more dependencies like this pillow, numpy, and so the data classes, etc. So it's really a complex graph there. Okay, so now we have already installed the dependencies. I think now we are able to run this Python script, right? But the thing is, bounce picture, my cat's picture, is saved in my local environment. And if you remember this isolated environment, I can't really find my target pictures, right? There is nothing there. We just clone the repo. Then the problem is how to like add the images, add the data set in a more general way, if we want to into this container. And one of the maybe the simple way is to run this command, docker copy. And it's similar to this Linux copy command. You just give the path of the source file and also the target. But the difference is the target or the source can be the container. Okay, so let's try that. So I have already like make a folder here, image, and there is nothing here, right? So the path in this container is application images. And let's go to find out bounce picture, WARA-SW workshop. And I think it's located here. And now let's run this docker copy command. So docker cp, and the source file is this bound.jpg. And the target file is, if you run docker ps, because the thing is we need to find out the name of this container. Interesting Snowy. Yes, it's a random name. So we have to find out the name by running docker ps, and then we can copy our file to this container. So the grammar is the Docker container's name plus the path. So it's dash application dash images. Okay, the command is executed. Now you see bounce picture is copied into this container, right? And finally, we can run the script. Python test Python input directory application images. output directory, application, images, results. Perfect. We have another error here. And it's a different error when we executed on my local environment. And it says, found no NVIDIA driver on your system. Okay, so my graphical card is missing in this container, right? It's super important. Like when you do a machine learning project, I have to rely on some GPU resources. But now it's a big problem. We don't have this GPU resources in the container. And I will show you how to address it later in this workshop. And for now, let's use device CPU instead. Okay, now you see it's executed successfully, and it's loaded the model, and it generates the target picture for us for bound. Okay, now bound's picture has been generated here. And if you need, we can also use this Docker copy command to copy this file in the container to our local environment. Though it's not convenient at all, but it's a way to do that, right? So if you have a running container and you suddenly want to add some files there, you can simply run this Docker copy command. Okay, so the first example stops here. Let me stop the container. Okay, so if you run Docker PS again, now we don't have any running commands, running containers here. Let's go back to the slides. All right, so we have already successfully used Docker to run this project, but we have so many issues, right? The thing is, what issues do we have? The first one is every time we need to install dependencies, right? When you introduce this approach to your friends, okay, I have a super amazing project. Try that with Docker. And then your friend has to, for example, run this Python 3 Docker image to start the container and install, check out our project, install dependencies, and run a script. So it contains several steps. And yeah, every time we need to start up the application manually, like this Python test, the command. And we don't have our favorite editor in the container, right? Everything is done in the bash, in the terminal. And if I am a big fan of the GUI applications, Sublime, VS Studio, then I don't have this access to the files in the container, which is very bad for me. And also, it's not easy to manage files. I don't want to use this Docker copy command so many times, like to move the file into the container and out from the container, etc. And then there is also no GPU support there, which is a big problem for some of the machine learning projects. And now we are going to address these problems using more features in Docker and to see finally what we can get. So first of all, let's try to address these two challenges, two issues. How to automatically install dependencies for our Dockerized containerized project, and how to start the application automatically. Okay, so in order to do that, I have to introduce you more concepts or more commands. So because as you have seen, we executed or we start our container from the existing image called Python 3.6. And then everything is started from that image, which acts as a template, right? So when you start from this Python 3.6 image, you have to install the missing stuff, the components, the dependencies by yourself. And the idea is whether we are able to create our own image. So everything has already been installed there. And then everything is started from our own image. So I can just, for example, add the pictures I want. And this can be done from this Docker commit command or the Docker file, the feature in this Docker system. So let me show you the first approach in the beginning. So Docker commit container repository. And the thing is, let me open a new terminal here. Okay, so workshop Docker version 2, and not really this project, sorry, but it's a Docker container, right? So if I run this Docker PS command, if I give the option -a, it means prints out all the containers in your local environment. So even the container has stopped, then I still have this container. It's just not running, but I haven't like removed the containers yet. So you can get this. So for this one, I think this is the very latest one. And this is the one where we install the projects and we run the actual command there, right? Okay, so you can use this command called docker commit, and then you can give the container name and also the name of the image, so repository and the tag. Okay, now we are going to make this container into the image. So the container is I initialize the running environment from the image, and the image is the template for creating new containers. So these are a pair of concepts. And now we can commit the container into image. So how about calling it enemy gan version 2? And we can we use this colon to separate the image name or the repository name and the tag name, just as Python colas 3.6. Okay, so enemy gan from container. I think usually prefer to use this dash, and everything is fine. Okay, so now it's executing this command, and it's actually transforming this Docker container into an image. And the benefit is you can create new containers based on this image afterwards. So if you run Docker images, the command, it gives you the full list of the images you have on your local environment. And now you see we have this enemy gan from container image, and the size is like 4 gigabytes about that. Okay, now if I run Docker run -it, and maybe I can also add this RM option, so it removes the container after we stop the container, the running container. And then the target becomes enemy gan. I think it can autocomplete enemy gan from container, right? Okay, so now I replace the existing image from Python 3 to our own Docker image, enemy gan from container. And then we have like this interactive interface with the target container. So it's running. And you see we have already had this application folder. So if we enter this application folder, perfect, we have the images, and the bounce image has been copied to this folder. We also have this project folder. So everything has been installed there. If I run pip install requirements here, you can also double check like the requirement already satisfied, because we commit our running container into an image, and then the start point becomes like this enemy gan project instead of the Python running environment, right? So this is like the example for you to feel, okay, we can create our own containers. So this container can provide you the full running environment. And actually this has already addressed like lots of our problems. So if we have the running environment locally and we want to invite our like teammates to try our project, okay, I just run the container and install everything, and then I commit this container to the image, right? And then I push this image to the Docker registry so that others can feel free to pull the image and try the project. But the thing is, if you recall the challenges we have, like this InProcess documentation, and also like the the code route, etc. The thing is, you just give him the Docker image, but actually he has nothing he has no idea about what's happening in this image, what you have installed, and what is a way to reproduce this running environment, right? So there is a better approach to do that, which is Dockerfile. And Dockerfile is also sort of the documentation for yourself, like try to remember how you set up this running environment. So the start point is Python 3.6, and we did lots of steps. And finally, we have this enemy GAN project. But the thing is the steps. After like quite a long time, we can still remember what we actually installed. Okay, so for Dockerfile, as an introduction, it's a text-based script of instructions. So it's really like a plain text. It's a set of instructions, and they are used to create the container image. Okay, and let's directly try that. Okay, so for this AnimGAN PyTorch project, this is my local environment, the host environment. And now I'm going to create the Dockerfile. Dockerfile, yes. And in this Dockerfile, the very first step is to define the start point or the base image in the as a concept. So the base image is the template or the basic layer of your image. So we start from that layer, and then we add some extra layers to the existing image. And you as you have already seen, we use Python 3.6, right? So it's defined by using from instruction. So from Python 3.6, and then our starting point is Python 3.6. And now the thing is how to document or how to record these instructions to actually set up your running environment, right? Okay, so the first thing, let me see, I have some notes here. The first thing is we can have like the working directory or the target directory. We run this, like make an application folder. And then in this folder, we can either use git clone, and then we give this project URL, right? We can check out like the target projects here. Another way to do that is we can use this copy command. Copy to this command or to this application command. And the difference is for this copy command, you can directly copy your localhost files into your target Docker image. And for the git clone command, so usually if you want to use that one, I would suggest to add a tag there. Because if you clone the repo, it always gives you like the latest, the head or the latest commit of this project, which can be different after you creating the very first Docker image, right? Okay, so then we can use this copy command to copy the target files to this AnimGAN project. Let's see. And after that, we should use the pip install command. Before that, let's use this one. So in Dockerfile, a new instruction called work directory means we set the working directory as the target path, and all of the following commands will be executed in this folder. So for example, if we set AnimGAN as the target folder, and then every command will be executed in this folder. Okay, so Python install requirements.txt. And what's the next? So we have already got the project and we have already installed the dependencies. And then I think we can, for example, to set up the entry point, right? Entry point, Python, and the CMD. So these two instructions, entry point and CMD, both of them can be used to set up entry points, starting points. And the thing is, entry point, you can, so usually for some of the good practices here, this CMD command can be the default argument for entry point. So if you use these two as a combination, for entry point, you give the executable name here. And then for the CMD part, you give all the arguments here. And then it's acts as a combination. And also if I want to change the default arguments, I can just run like Docker run plus the arguments, and then the entry point stays the same. And I think this can be found in the Docker's official document. Let's see. So Docker entry point versus command. Probably the first one. But there are many tutorials or discussions about this. So if you feel interested, like how we can properly use this CMD and the entry point instructions, you can just Google it and take a look, like how to use it, how to combine them, etc. Okay, let's switch back to the terminal. And to save some time, I will directly show you the modified Docker image. I think I have already saved it here. Yes, so you see we from Python 3.6, and then we copy all the files to the application folder, and we set up the working directory here. Then we install dependencies and define the entry point. And here because of my local environments issues, I set up the default device to CPU. Okay, now let's do that. And to build the Docker image using the Docker file, you will use Docker build command, and you give the Docker file's path. Usually it's your current folder, and then you have to define the tag of your target image, or the name of your image. Okay, I think we can use this one, and by default, it will add this latest version to your target image. I think it takes some time again. And the thing is, when you run this Docker build, it will execute all the instructions in this Docker file. And as you see, this is hash values. It means you are building extra layers of the existing Docker image, right? Because the starting point is Python 3.6, and then this is the starting point. This is this image. And then it copies the files to the image, and then we add one more layer of this image. So it's a stack, like the stack. So you have the new layer of the image, and you have the new image here, actually. And then it keeps executing the steps. So for this, it sets up the working directory, and then it's a different one, right? The default directory is the root folder. That's why you have different layers. And finally, okay, so it also removes some intermediate containers. And finally, you run this dependency installations there. And you get, after installing it, you get a new layer and you get a new image. And finally, you have your own Docker image there. Okay, not sure how long does it take, but I think it's almost done. And after that, we can try to check out the image we just built. To use this time, I just check the chat box, and I don't see any problems here. So if you have questions, feel free to ask. It really takes some time. But I think I can, let me double check the slides. And I think I can continue with this one. So for this Python 3.6, for the hello world Docker image, I mentioned several times about Docker registry, and the default Docker registry for the Docker community is this one, Docker Hub. So if you visit their website, Docker Hub, you can like register a free accounts there, and then you can publish your own images to the Docker Hub. And of course, you can search different Docker Hubs. For example, PyTorch, right? Our project is using PyTorch, and now you see, actually it has lots of different PyTorch containers. So the idea is you can use Python 3.6 as your start point. You can also use other Docker images, which has already like installed PyTorch there. But just note that the thing is, sometimes you don't really need all the components, all the installed components, for example, in this PyTorch container. And then the image could be super large for you. And some of them, the size is, we can reduce the size, right, to make the project more thin and more convenient for the others. So just pick up a proper base image, and then we can build our images on top of it. Okay, so now we have some warning messages. I think it should fine. It mentions like we are running PIP as a root user. Yes, because it's in a container, and the default user is root in that container. And then we set up the entry point and also the default arguments there. If we run Docker images, we will see a new image here, and began latest about 1 minute ago. And then this one is built from our Docker file. Right. The benefits is you don't like necessarily need to provide the 4 gigabytes Docker image to your friends, but you can just provide the Docker file to your friends. Then the friends or the other reviewers, they will know how you construct your running environment. And they can run Docker build on their local environment to reproduce your running environment. So this is the better way for you to generate Docker images. Okay, let's try a little bit. So Docker run, I think now we don't need to interact with the terminal, with the container, right? Because we have already defined the entry point. So we can run, use this Docker run. I can remove the container afterwards, and then and begin latest, right? Now it becomes like easier than before. We don't need to run the commands. We don't need to provide extra options because everything has been defined in the Docker file. And you see, as you see, the picture has already been generated. Okay, let's continue with the Docker Hub part. So for the Docker Hub part, I will show you. The first thing is you can, there are so many Docker images on the Docker Hub. So you can just search what you want. I want Python, yes, search Python, and then you have Python images. I want Ubuntu, then you have Ubuntu images on Docker Hub. And then you can use Docker run plus the image name to create your own, your own running environment and do some modifications there. And the second thing is you can sign up. You can use your own account to publish Docker images. So for example, not sign up, sorry. You can, if you don't have an account, sign up one, it's free. If you have already got one, then let's just sign in with my account. And you will have your own dashboard here. So you can like push different images and you can share these images with your teammates or with the reviewers if you like submit some source code or the running environment there. Okay, this is about Docker file and Docker Hub. So after building this Docker image, you can use Docker push plus the image name plus the image name. So this one is enemy-gan latest to push this registry, to push this image to the registry. So just follow the naming conventions. You see request access to the resources denied. Why? Because this one. So I have to use my own Docker command account, and then I have to construct the Docker image name, something like this. So this is my Docker account, and then plus the repo. So if you run Docker push something like this, it will work as long as you have already logged in using this account. I will skip this step. It also takes some time to push like 4 gigabits to the Docker Hub. But the idea, I think it's pretty straightforward. Okay, back to the slides. We have already addressed the first two issues. Now we using Docker commit or Docker file, we are able to like define or install the dependencies directly for our own image. And then we can also like start the application manually. But the thing is, we don't have our like a favorite editor. If we want to like modify some source code directly, right? It's not convenient to build your image every time when you modify some like single line of your code. And also it's not easy to manage files. We haven't addressed this Docker copy command yet. You will not like always generate pictures for BOM. You will have your own like pictures or your own data sets. Okay, so for these two challenges, I will introduce you a feature called Docker volume. And Docker volume is like the mechanism for you to interact with the Docker's file system. And by using Docker volume, you can separate the data, the file from the container. And you can share this set of data with the other containers. Okay, so the first or the important principle is any changes they won't be seen in another container. So I think we have already clarified this. Everything is started from the base image, for example, Python 3.4, 3.6, or the enemy-gan image. Everything is started from there, and everything is isolated. So if you create two containers using the same base image, then you still have two different running environments, and you can't really like exchange files into these two containers unless you are using Docker copy command or something like that. But how to do it in a more convenient way, right? So the general idea is to use this Docker volume feature, and Docker volumes, it provides you the ability to connect like the specific file systems, the path to the container or to the host machine. And the basic the basic approach to create the volume is run Docker volume create with a volume name. And then you can run the container with this image, right? And attach the created volume to it. I can show you the volumes I have currently. So if you run Docker volume ls, and then you have a list of the volume, and you see I have different volumes. These are automatically generated by Docker, I think. And these are created by me with the name. So if I have a container, I can attach this volume to the container, to the path of the container. And then I get the files of this volume in the container. But this part, I will not demonstrate it because based on our project, it's not our goal, right? You can like share the volume with different containers, but currently our issue is how to conveniently add pictures. We don't want to copy the picture from our host machine to the container, but we want to just, for example, share this folder in the host with the container, and you generate the pictures from it. So that's why we need another type of volume. So this one is a volume that is managed by Docker. It's convenient. You don't need to care about the path. right? You just create the volume and attach it. But for this one, band mounts, you can like specifically define the path to your local host location. So you define the folder of your host, and then you attach this folder to the target container. All right. For example, for this one, images, right? Currently, we have this bound.jpg picture. I can also add others. For example, samples. I think it has some samples. Yes, if we add one picture in these images, now we have two pictures. And if you check the results and remove it, so there's nothing in the results folder yet. Okay. All right, so currently we have this image folder and it contains two images and there is nothing in the results. If I run this Docker run, I can remove the container afterwards. And also if I attach the current images folder. So PWD, this one is the environment variable in Linux systems. And it gives you the current path to this project folder. So if I use echo PWD, you will see like the current working folder, right? And then docker run --vm-v, this part becomes this one. So it's just to save some like typing efforts. And then you have this -v band volume, band mount. You mount this images folder to the target folder. Because in our enemy GAN Docker image, we have this working folder, right? The entry point is to generate pictures in this application images folder. Okay, and then we can really run enemy GAN latest Docker images with this blend band commands. Okay, so after that, let's take a look. If everything goes well, we should be able to see the results in our local host machine, right? In the host machine's image folder, because it's mounted to the target container. And great. So by default, the container does not have this one.jpg picture. Now it can handle it, and it's saved in this images folder. And also it outputs the results into this results folder. And still this folder is directly like managed by your host location. So this is the idea of Docker volume and band mounts. So how to attach your host folders to the target container. Actually, this is an interesting feature because for some of the Docker images, they just provide you the development environment. So for example, if I'm currently doing a Python project, you can use this Python 3.6 or some other images to set up the development environment, which means it only provides you the running environment, the compiling environment, but it does not contain your project. But I can easily use this like band mounts to attach my project folder to the container. And then you have both your projects and your running environment. And the convenient part is you can still use your favorite editor on your host machine because the folder is is a part of your host machine, right? Yes, so that is the idea of Docker volume. And if we recall the issues, we use Dockerfile or Docker commit to address the first two. And then we use Docker volume to attach our localhost folders to the target container. And then we address this, the second two issues. And then the final question is where is the GPU support? It's pretty important. For example, if you have some cloud computing resources and they require you to, for example, run your experiments in a container, and then you have to rely on their the GPU resources, right? And how to do that? Usually, you can use this pretty nice tool called NVIDIA Container Toolkit. And if you take a look here, it gives you the concrete steps about how to install it. So it's pretty straightforward. If you have a graphical card on your laptop or your desktop, and if you want to do some experiments here, you can just install this toolkit. And then you can run sudo docker or docker and run with this flag. So that's GPUs all to enable the GPU support. I can directly show you here. So if we run this NVIDIA image, you see it's still like a starting point. It's an image name, and this is the command or the new entry point. So we will run this command inside this container with the flag GPUs all. And now you see it outputs the information about my graphical card here, which means you have already attached your graphical card to the container. And we can reuse this. So if we add these GPUs all to our enemy gun Docker image, then the created container will get the support of the GPU, the resources of the GPU. And it's pretty nice that we have already addressed these 5 different issues. A little bit more information before we taking a break. So for the first part, I have already demonstrated like how we use containers, how we use Docker to create your project, provide the running environment in a single container. But sometimes it's possible that you need several containers, like which running as a whole. For example, you have the decentralized application, you have a distributed algorithm or system to calculate different parts of your income. And then it's a good idea to have these multiple containers set up, because if you run everything in one container, right? And if there is an error happens in this container, it's mostly likely that the container will be terminated, and then maybe you have to start from the scratch. So it's a trade-off. So for the single container, yes, it's the complete convenience. I would say it's convenient. Like you just start up one container, and then you get everything ready and just wait for the output. But the thing is, it's not really convenient to scale up the computation. For example, if I want to run it in parallel, or if like a Hadoop cluster, we can do the MapReduce in different Docker containers, then it would be better to have multiple containers support. And also you can isolate different services, like the database, like the computation components, or some interface, web front, etc. You can really separate them into different containers. But the thing is, the more containers you have, maybe the more complexity you have also. And for this part, because for this enemy gun project, I don't really find the idea of how to separate this into different containers. So I just show you another example. I use this one in the first workshop. So I have this to-do application. It's just a note application with a web interface. So I can type different to-dos and check it to mark it as completed, etc. And in order to save it, I can use the database to persist the data. And now I can have 2 different services, right? So the to-do application, it can act as the front end, which interacts with the users, and the MySQL database, it can be the backend to save all the data, all the to-do informations. And in order to do that, I can use this set of commands. So for example, let's create a Docker network. I have already got it. So I have this error. So network with this name already exists. So otherwise you have the new network. And the thing is, we can create this network, and we can attach different containers into this same network. And the idea is all the containers can communicate with each other within this network, right? Okay, so the second part, we run the MySQL Docker container to provide the database support. And you see there are several options here. -D means detached, so we don't need to interact with the container. We just put it in the background. And then we have the network defined. Okay, we use this to-do application network. And also I can use the volume, right? I just introduced you about Docker volume. So now we are able to use this volume in this container to save the data. And the benefit is if I delete the container, and then I can just create a new MySQL container, maybe with different versions, but with the same Docker volume. So I can restore my data back to this container. Okay, now let's run this MySQL container. And you see if I run Docker PS, then I have this MySQL container running here. And finally, I can run the to-do application container here. And I have already pushed it into the Docker Hub. So you can also directly run this because it's saved remotely on the Docker Hub. And here we go. Okay, so this is something new. So if you are running some web interface or some applications which needs to open some ports, you can use this expose feature command in the Docker run. So you can just expose your localhost 3000 port to the 3000 port number of the target container. And by doing this, you can directly visit like the container service via your localhost because it's a sort of port forwarding here, right? And you see, I have already got some to-dos here, and the reason is why? Because of this, right? We have already attached the volume. This volume has been created on my localhost environment, and it contains my previous data of this application. Okay, so now we have the running to-do application with two different containers. So they act as a whole. But still, we have some problems here, right? We can provide the documentation, like, okay, you need to create network, you need to create the database and the application container, but still it's like you have to copy paste several times to create this whole setup. And especially when you want to stop the container, I have to use Docker stop to remove this one and to remove this one. So it's a little bit inconvenient. And now a new approach to do that is like, what if we don't want to run or execute this Docker run commands every time? And we can use this one called Docker Compose. So you can also have other tools like the Docker orchestration tools, like the Kubernetes tools. They will have a more advanced orchestration feature for you. So it monitors your containers. It helps you to restart the containers when there is an issue. But this one is pretty convenient, and it's sort of easy for us to deploy some testing environment. Because after installing Docker Compose, you can just define the Docker Compose file, which contains all the containers, and then you use Docker Compose app-d to like start the application. So for this, I can also show you. I have prepared some Docker Compose examples. This one is for our to-do application. And if we take a look at this Docker Compose file, and you see it defines the version of this Docker Compose, and also it defines different services, right? This part is the Docker run commands like that we previously executed. So for example, for this application, we use the to-do application image. We expose the port, And also we set up the environment variables. This one could be used to connect to the database. And also for MySQL, we use another image with different like environment names and volumes. So by default, Docker Compose will create a new volume for you with like a prefix, like the project of this, the project name of this Docker Compose file. And if you like, you can also like specify it. It's the external volume, and then you give the existing volume's name of your in your local environment. But the thing is, now you can just run Docker Compose app-d, and then you have two different containers running here. And you will access your application here in a second. Yes. And you see, because it creates a new Docker volume, it does not like provide you the previous inputs here. And also you can check Docker Compose logs, etc., to see how is the project going and what are the errors in your different containers, which is super convenient. And when you want to close your project, simply run Docker Compose stop. And now you just close all the containers. If I run Docker PS, nothing is there. So this is quite like a convenient. For example, in our project, imagine if I am the owner of this AdminGAN project, I can provide you the Docker Compose file, right? Then you can build your running environment of this project to try it in the Docker, in a Docker container. And also if I need several different services, I can provide you the Docker Compose file here. And then you check out the project, you run Docker Compose app, and you have the full running environment locally. Sometimes I directly use this to deploy some like web services. For example, if I would like to write some blogs or like open my own personal website on the internet, I can like buy a domain name, buy the virtual machine, and then I just use the Docker Compose to construct this like the project or the database, etc., to set up my own website. By doing so, for example, I can use this WordExpress Docker Compose file, and then I just use Docker Compose app to run all the containers, right? And if you see, I forget the port number. I think it's all. And then I have this WordPress running locally, and I can set up my own website. Good luck. And something like this. Okay, I must provide the email. Okay. Log in. Do you still remember the password? That's so bad. Okay, anyway, so I just would like to show you like Docker Compose is pretty convenient. Like if you have some big projects, either your own project or some projects that you want to use, you can use Docker Compose to easily like set up the running environment. For example, also for this overleaf project, if you like write scissors in LaTeX and if you use overleaf, overleaf also have this community version. Like you can, it's open source and you can run it locally. You can even create your own overleaf project by doing this using Docker Compose. But I think I need to close WordPress first, just to avoid some port conflicts. Docker Compose done. And try to switch to overleaf, Docker Compose app-d. And now you see it has different volumes and network and also different containers like MongoDB, Redis DB, and also maybe the shared LaTeX frontend, right? And now I can use localhost to visit my overleaf. And of course, it's bad gateway. I think it's still like initialize this. It takes some time. And now you have a fully running overlay community edition here. So it's pretty interesting if you would like to try some projects using Docker or Docker Compose. Okay, so I think this is the end of the demonstration. Docker done. Let's close this. Let's check if we have already mentioned everything. Okay, multiple containers, Docker Compose. You define a set of different services, and then you run Docker Compose to start all the containers automatically. And maybe for the next workshop, if you really feel interested and you have already gained more experience of Docker, we can have more discussions about this, like the orchestration of Docker containers, how to use Kubernetes, how to give advanced monitoring of or observability of your system, target Docker system, etc. How to do this DevOps stuff. And then I think, yeah, we can have another workshop about it. But for today, for now, I think that's all for the demonstration. And do you have any questions? Okay, I think there are some questions in the chat box. Let's see. Yes, Truth. How would you need to edit your Docker file to have this band mount done automatically? Good question. But I think for the Docker file definition, let's see. I don't think you need to define band mount in the Docker file. Because for the Docker file, you only defines the structure of your Docker image, right? But for the mount, it's done on your host machine. So for the Docker file, it's not really necessary to know the information of your host. You just give the running environment. But then if you want to attach a folder, you can use the flag when you start the container. But anyway, let's see. I bump to Docker functions like volume if this is the solution. Yeah, that's also what I think. I think it's possible to do it in the Docker Compose file, right? Because for Docker Compose, you set up this running environment and you can define the volumes, how to band it, how to use the Docker volume. But for the Docker file, I don't think you need to do that. Or I don't think it's possible to do that. Hopefully it answers your question. Okay. I think that's it. And also thanks Xiaomeng for the feedback.
I actually put a question in the Google Drive notes.
Let's see.
So but it doesn't matter. It was basically the same. So my question was also, I heard of one service, one Docker container or image.
Yes.
But then when we want to do the reinforcement learning benchmarks and different stuff, what is then the best way to do it? Do we just put everything in a Docker container or what do we do?
Okay, so to be more specific, for the reinforcement learning, do you have lots of computational jobs in parallel or different services that you have to run in parallel? Or you have a single entry point, like a single command to start everything?
Both cases. So,
okay.
Yeah.
I see. Yeah, so I think it's a case by case problem. But for me, usually if I have a single entry, I have a single command. Still, it's fine to have a super big container that runs everything, because as I said, it reduces the complexity, right? You just define the big container, and the storage is not a problem. So you run this as a whole, and it gives you the output directly. But if you have multiple entries and you have, for example, it's by design in a distributed way, it communicates with different components using RPC or some other mechanisms, then I think it would be nice to have a set of containers. And the good thing is you can define or you can scale up the workers easily. For example, for MapReduce, I can have this Docker compose file, and I can define the number of workers. So you can have one single controller, but if I think I need more workers, I can easily scale up the workers and do this parallel computing easily. So that's my opinion. So single entry, yes, it's fine. So we don't care if it takes you 10 gigabytes as a Docker image. But yeah, for some distributed designs, yes, it would be nice to have multiple containers.
Yeah, I also wrote this question early on.
Yeah.
And I think with the Docker Compose, you basically answered it then.
Yeah. Thanks for the question. And yes, there are like best practices, like the discussions about this best practices of Docker. And usually they mention like one service per container, because I think this is because you define the entry point. And usually for the entry point is a single command that starts one process, which like handles sort of the functionalities there. They do have some mechanisms to manage the services, like you run multiple services in one container, but yeah, people usually don't recommend that. Okay, so then I think we don't have other questions here, right? Okay, perfect. So we have already addressed the first two parts, like the concepts and also the demonstration of Docker. And now it's time to have some discussions or have the connections between Docker and the reproducibility. So how to do this reproducibility improvement using Docker, using what we have already learned just now. And to recall the technical challenges we have already discussed, I think to summarize, if we want to address dependency hell in this case, in this scenario, we can use Docker and we can provide other researchers with the Docker image, right? And in this way, like all the software has already been installed and configured and tested. So basically, you provide your runnable experiment to the other researchers with the same running environment. In this way, you have already installed all the dependencies, and they just pull your Docker image and run a container on their local environment. But maybe some more discussions here, like if the data files are not too large or are too large, for example, for some machine learning projects. And then we can have some more considerations about this. So if the data files are not too large, like maybe less than 1 gigabytes, then I think you can directly like include them in the image, because the network is pretty good. It's not a big problem nowadays. And then we can provide a bigger image, but with more convenience. So this image contains for example, the training data or the pre-trained model, etc. Then they can just like execute this single container and run what they want to test the functionalities. But the thing is, if you containerize the training process, like you have raw data or the super big data set, and then you train your models based on this data, then it might be a problem. Like you can't really attach a 50 gigabytes Docker image to, or provide this image to the others. So it takes lots of time, and I'm not sure, maybe it has some like limits about the size of the Docker image. And in this way, you can recall what we have tried about the Docker volumes or the blend mounts, right? You can separate these data files and then provide another place, another like a platform that can serve this data set. And then they just download the data set separately and attach the folder to the target container. So for example, for this Zenodo platform, if you have already tried it. It's pretty like popular in academia, right? You just attach the data sets also with the similar format, author's abstract, and also how to use it. Maybe also the link to your papers. So for example, you can upload your data sets here. And then for the other researchers, they can download, they can run your image and download the data set to attach the folder to the target container. Okay, so secondly, to address this in-process documentation, we also discussed like you can push your Docker image to Docker Hub, and then I can pull the image and test your project. But the thing is, I don't know how you set up this Docker image and what's the steps to set up the proper running environment. And to address this, or to address the relevant challenge, the issue in InProcess documentation, we can provide these Docker files. It's just a text file, and we can directly put it into your project repo. So by providing Docker files, we can, for example, help other researchers to build your projects, right? It's easier to be stored and shared. It's also easier to track the changes. So for example, if I upgrade some dependencies, if I add some files, I just modify these Docker files, and everything is reflected as a commit. And for example, if you are using Git. And then we can also provide the human readable summary of the environment. You can add comments there. You can also like tell developers what different kinds of environment variables you have set in your image, what are the entry points, etc. And also it's pretty straightforward for the others to customize the Docker image, because I can customize the environment according to your Docker file. Okay, and also to address this code rot, because it's like the long-term effect with the time of your research going on and the development of your own tool or framework, code rot might happen. And also to eliminate the issue, we can, for example, archive the Docker image, use the tag. For example, when I submit a paper, I can push this running environment to Docker Hub with a specific tag. And in this way, this tag, this image is like explicitly connected to the version of my submitted paper. So I can keep working on my research project, but I can provide different Docker images in this way. Okay, so this is just like a short summary of the connections between Docker and the reproducibility, like based on the demonstration, what we have learned and what these kind of features can help us to improve the reproducibility of our work. And I think we can have more discussions here if you have any. And before and after that, I can show you how like you can practice more about Docker and what platforms you can use, etc. But yeah, first of all, do you have any questions about this?
Maybe I can ask a question.
Thank you.
So how would you use the Docker and Conda together in your workflow? Do you develop in Python? Like, what's your advice there? Like, if you want to use Conda to separate your environments locally, then yeah, how do you work with that together with the Docker?
You mean how do you how do I like use Docker for my daily work, daily research?
Yeah, so like, would you recommend going straight for containerization while you develop your work, or would you containerize when you're done? And if you containerize, then would you include some of your Conda environment, or do you see your Conda environment as something you use just when you do it?
Yes,
like, how would you...
That's a great question. Yeah, thank you, Truth. Now I see your point. So yes, I personally really prefer to use Docker for my daily research, but I fully understand, or my own like consideration is still you run this Docker like thing and you attach an extra layer of your work, right? So sometimes it just feels like convenient. I just run everything locally without Docker, and then I just do my own research experiment. So for me, for my personal opinion, I would say if it's an ongoing project, or it's really like a start from the beginning, I have a new idea and I want to try lots of stuff like during this research process, then I'm indeed I think I will start from using the local environment, the host environment first. But the thing is, you have to try different environments. For example, I come across like many different projects. If I want to use this one for my project, etc., then I have to reproduce or run their experiment. And usually in this way, I will use Docker to help me to run this experiment. And maybe a more concrete example is I do a lot of Java development. And for this, I run different libraries or projects, and which maybe requires different JDK versions. And in that case, I will directly use Docker to attach the project folder and try to build and run some tests there. This is the very first step. I think, yeah, we just try my own code. I tried it locally. Other projects I try with Docker. And the second phase is how to improve this project, improve my project for the others. And in this stage, I usually provide a Docker file. Like you can install the dependencies and all the other stuff in this project and using Docker. And finally, I think the goal is to, for example, for our PhD studies, you submit papers, right? And when you submit paper, you present the experiment results, and there are many reviewers who feel quite interested in your approach, and sometimes they just want to like reproduce the results or use the tool. And in this way, I think it's even a stronger motivation for me to provide Docker Compose file and the Docker images there. So currently, I use Docker a lot, as you see. Lots of different images and containers, and also for some projects, maybe it's different. It's slightly different for different students, because for me, I use like different databases or some other like web services, and then I can set up these services using Docker and just expose the port number to my local machine, and then I can use it directly. I don't know if it answers your question.
Yeah, but I think then I take with me that you sort of use Docker instead of having this Conda environment that I usually be using in Python.
I see.
With Docker, I guess you get a lot more than with Anaconda.
Yeah, but I think it's also a question like how common the environment is. So if you have multiple projects and the environment is pretty similar, then we can really design the more convenient approach for our experiments. So for example, if for 2 or 3 projects, we have different running environments, different dependencies, etc., then of course you can install it locally and yeah, you just run it. But if the environment is pretty shared by these projects, so then why not we can have this like a development or running environment there, and we just bind the folders to this environment when we try these different projects.
Oh, great, thanks.
Thank you. And maybe an extra comment here is sometimes I use cloud like services or cloud resources, and then I really don't like to install all the stuff there again, especially for sometimes I have to create like a new instance pretty often. On this cloud platform, I create a new virtual machine and then I install everything there. But nowadays, basically, I create a new instance, I install Docker, and then I pulled my image from Docker Hub. So maybe it's more convenient if you have to switch the environment. You can't really feel it if you keep using your own laptop. But one day you have a bigger project, you have to switch everything to the cloud. And then maybe Docker could be quite helpful. Yeah. And do we have other questions? If not, I will start part 4. And this part is more flexible and is more interactive. So part 4, you will try Docker by yourself. And I will provide you some resources like the platforms and also the exercises. And then I will be standby. I will create another Zoom channel. So we will close this one, and you can keep trying by yourself. If you have any questions, just join that Zoom room so that you can ask questions, etc. I will stand by until 5 p.m. so I can help you. And for this part, we will use the tutorial called this 101 tutorial by the Docker website. I think it's sort of official tutorials, which is pretty nice. And for the platform, we will use this Play with Docker platform. And if you have already installed Docker, you can also try it locally, like if you get Docker installed, but it's not a problem for you. So let me show this platform first. So for this Play with Docker tutorial, you will read the tutorials. You can also have this lab environment. So this is an online environment, and you don't need to install Docker locally. In order to use it, I think you need to register an account on Docker Hub. And after that, if you click login, I think I have already input my password just now during part 2, right? And then you will be redirected into this dashboard. And here you can add new instance to this dashboard or to this session. It basically acts as the virtual machine. And after that, you have this node 1 running, and you also have the terminal here. So it has already installed Docker, right? You don't need to install it, and it's pretty convenient. You can try everything, try anything you want with Docker here. And how to open the tutorial? Let's take a look here. So for this tutorial, 2 ways to open it. If you would like to try Docker locally using your laptop, you can run this command, docker run -dp. So you detach the container, and you expose the 80 port number. And this is the default number for web services. So after that, you can use something like this localhost to visit their tutorial web page. Right, and for this Docker online platform, we have another command here, docker run, and then it's the container name and tag. So if on this Play with Docker platform, you can run this image, and after run it, if you open the port, you will see there is an open port label here, and just click this port number. You will have this the web page of the target container. Now you see the tutorials here, and for the following 2 hours, or for the following 1.5 hours, you can try some of the tutorials, a part of the tutorials here, especially for this part. I think before this multi-container applications, you can really try the commands I just showed to you. Okay, so the first one is about their application. This is a to-do application I have already demonstrated. So how to get the source code using this command, and how to make some modifications and run the actual application, etc. So you can follow the steps here and make the application running. And after that, you will have the task to Dockerize or containerize the application, like how to update it, how to share it, how to use the MySQL database or Docker volume for this application, etc. So just start their tutorial container and then take a look at the instructions here. I think you will follow the steps there and try the Docker commands. If you like more challenges, of course, you can, for example, pick up your own research project and maybe write a Docker file and install something and publish your own Docker images, which is super good, I think. Okay, so this is about the hands-on exercise, and I think that's it. And I think I will open the private channel here just to double check if we have other questions. Seems not. And the chat box is also empty. Okay, then I think it's we can really start now.